The third problem is charges 2 microcoulomb, 4 microcoulomb and 6 microcoulomb are placed at the three corners A, B and C respectively of a square ABCD of side x meter. Okay. Find what charge must be placed at the fourth corner so that the total potential at the center of the square is 0. See, here they have given, if we consider a square, okay, in a square they have given the charges at A, B, C respectively, that is 2 microcoulomb at the corner A, the charge is 2 microcoulomb, at B it is 4 microcoulomb and at C it is 6 microcoulomb. Now we have to find out the charge at the corner D. Let it be QD, that we have to find. They have given the sides of the square are x meter. In a square all the sides are equal and two diagonals are equal. Right. Now write the two diagonals BD and AC. Okay. So the two diagonals BD is equal to AC. At the point of intersection of the diagonal, let us consider the point as O. That is nothing but the center of the square. Okay. So at the center of the square, they have given the total potential is 0. That is total potential at the center of the square is 0. Now, so by using this, here they have given the total potential at the center of the square is 0. We know the expression for potential, electric potential as 1 over 4 pi epsilon naught Q by R, where Q is the charge. So R is the distance of the charge from the point where we are measuring the potential. Okay. See, here they have given the resultant potential at the center of the square is 0. By using the superposition principle of system of charges, so we can write the total potential or resultant potential is given by VR is equal to 1 over 4 pi epsilon naught into. So at the point O, the resultant potential is due to the charge at A, charge at B and due to charge at C and due to charge at D. So we can write it as, so QA by the charge at A is at a distance AO. So from the center of the square, right? So plus second charge is QB divided by the B point is at a distance BO plus, so the third charge is at C point, so QC by the distance is CO. So plus we can write the fourth charge is QD divided by the distance is DO. Right. Here we can write the diagonals BD is equal to AC. And if we divide the diagonal BD into two equal parts, that is nothing but BO and OD. So AO here, this AO, this BO and CO and DO are all equal. So AO equals BO, that is equal to CO, that is equal to DO. Okay. So now we can write the total potential as VR is equal to, here they have given the total resultant potential at the center is 0. So we can write 0 is equal to 1 over 4 pi epsilon naught value is 9 into 10 to the power of 9, that into QA, that is charge at A is 2 microcoulomb. So we can write 2 into 10 power minus 6 divided by the distance is A. Plus second one is QB. QB is 4 microcoulomb. So we can write 4 into 10 power minus 6 divided by the distance BO, that BO is equal to AO only. Plus the third one is QC. QC is nothing but 6 microcoulomb. So 6 into 10 to the power of minus 6 divided by the distance is CO. CO is equal to AO. Right. Plus the fourth one is QD, that we have to find out, divided by the distance is DO. This DO is also equal to AO. Right. So now here we can take AO as an LCM. So 0 is equal to, we can write 9 into 10 to the power of 9 into, so by taking LCM as AO, we write 2 into 10 to the power of minus 6 plus 4 into 10 to the power of minus 6 plus 6 into 10 to the power of minus 6 plus QD. We have to find out this QD value. Now cross multiply this. 0 into, if you cross multiply, we get 0 into AO. This goes to numerator and this comes to denominator. Divided by 9 into 10 power 9. That is equal to, see 0 multiplied by anything is 0. 0 divided by anything is 0. So that is equal to, remaining here is 2 into 10 power minus 6 plus 4 into 10 power minus 6 plus 6 into 10 power minus 6. Here, so all multipliers, that is 10 power minus 6, 10 power minus 6, 10 power minus 6 are same. So we can write 2 plus 4 plus 6. That is, so 2 plus 4 is 6, 6 plus 6 is 12. 12 into 10 to the power of minus 6 plus QD. Okay. So here 0 multiplied by anything is 0. Now take this QD to this side, or 12 into 10 power minus 6 to this side. So we get QD is equal to minus 12 into 10 to the power of minus 6 coulomb, or it is nothing but minus 12, 10 power minus 6 means micro. So minus 12 microcoulomb. That means the charge that is placed at the fourth corner in order to make the resultant potential at the center of the square 0 is nothing but minus 12 microcoulomb. Okay. The fourth problem is ABCD is a square of side 2 meter. Charge of 5 nanocoulomb, 10 nanocoulomb, minus 5 nanocoulomb are placed at corner A, B and C respectively. What is the work done in transferring a charge of 5 microcoulomb from D to the point of intersection of the diagonals? Okay, so here they have given ABCD is a square. Okay, so now take here A, B, C, D is a square. Here at ABC, we are having the charges as 5 nanocoulomb, then 10 nanocoulomb and then minus 5 nanocoulomb. Okay. So then, what is the work done in transferring a charge of 5 microcoulomb? Here, we have to transfer Q0, that is 5 microcoulomb, from D to the point of intersection of the square. Let us take this point of intersection as O. So from D to point O, we have to move the charge Q0. Okay. So in order to move this, what is the amount of work that we have to do? That we need to calculate. So this square is of side, they have given 2 meter. Okay. So for that, let us consider. So as usual, for the first, we have always have to write the expression, formula, that is formula for electric potential is nothing but V is equal to 1 over 4 pi epsilon naught Q by R. Right, this is the formula. In order to transfer the charge Q0 from D to O, from the point D to the point of intersection, we need to do some work. That work done is nothing but in the previous problem, in the second problem itself I have told you, the work done is nothing but, so potential difference into the charge that we are moving, that is dV into Q0, right. So potential difference means here we need to calculate the total potential at D due to all these 3 charges and total potential at O due to all these 3 charges. Okay, so after that we have to find out the potential difference. So for that, let us calculate the total potential at the point D is given by Vd is equal to the formula by using the superposition principle of electric potential due to system of charges. We write the electric potential at D is always equal to 1 over 4 pi epsilon naught into. That means the total electric potential is nothing but the algebraic sum of the potential due to the individual charges. So we can write Vd is equal to 1 over 4 pi epsilon naught. Due to the charge at A, we write QA divided by the distance from D to A is AD. Okay. plus the second one is QB. Charge is placed at the point B. So QB, and the distance from B to D is BD, plus the third charge is placed at C. So we can write QC divided by distance from C to D is nothing but CD. Okay. So this is the total potential at the point D. So then, in order to calculate all these things, we know AD value and also we know CD value, but we don't know the value of BD, right? We need to calculate that. For that, let us consider the triangle that is ABC. Here the triangle ABC is nothing but right angle triangle. So we can write. So by using this right angle triangle ABC, we write AC square is equal to AD square plus BC square. We know the value of this AB square and BC square. So AC square is equal to AB means 2 meter. So 2 square means 4 plus BC means again 2 meter. 2 square means 4. So that will gives you 8. So if you take the square to this side, it will become square root. Therefore, AC is equal to root of 8. Root of 8 means 2 root 2 because 4 into 2. So you will get 2 root 2 meter. That is the value of AC. Okay. So AC will be equal to, diagonals are equal in the case of square. Therefore, AC will be equal to BD, that is equal to 2 root 2 meter. So if we want to find out AO, OC, BO and OD, this AO will be equal to BO, that is equal to CO, that is equal to DO, that is equal to AC or BD by 2. So AC is 2 root 2. 2 root 2 divided by 2 will be equal to root 2 meter. This is the value of AO, BO, CO and DO. Now, so in order to find out VD, electric potential, so at the point D, due to these three charges, so now substitute the value. So VD will be equal to 1 over 4 pi epsilon naught means 9 into 10 to the power of 9, that into, so QA means it is nothing but 5 nanocoulomb. So 5 into 10 to the power of minus 9 divided by AD. AD means A to D distance, that is 2 meter, plus, so QB means at B 10 nanocoulomb charge. So 10 into 10 to the power of minus 9 divided by, so by BD. BD value that we know, that is 2 root 2. 2 root 2 plus, so QC means minus 5 nanocoulomb. So plus into minus is minus 5. Nano means 10 to the power of minus 9 divided by, so the value of CD. C to D distance is 2 meter. See here, plus 5 into 10 power minus 9 by 2 minus 5 into 10 power minus 9 by 2 gets cancelled. So we can write VD is equal to 9 into 10 to the power of 9 into remaining is 10 into 10 to the power of minus 9 divided by 2 root 2. So this minus 9, 10 power minus 9, 10 power plus 9 gets cancelled. So the remaining is 9 into 10, that is 90. 90 divided by 2 root 2. Okay. Or 2 ones are 2 5s are. So 45 divided by root 2. So that will gives you the value 31.82 volt. Okay. In the same way, we have to calculate the total potential at O due to all these three charges. Therefore, VO is equal to 1 over 4 pi epsilon naught into the charge at A is QA divided by the distance from A to the O is nothing but AO plus QB, second charge is at B, QB divided by the distance from B to O is BO plus at C the charge is QC, QC divided by from C to O distance is CO. Okay, now substitute the values. So VO is equal to 1 over 4 pi epsilon naught means it is nothing but 9 into 10 to the power of 9, that into QA means 5, nano means 10 power minus 9 divided by AO. See, AO is nothing but here AO, BO, CO, DO are all equal. So that is nothing but root 2 meter. Therefore, we can take these as root 2 as LCM. Therefore, root 2. Then in the numerator it is QA plus QB plus QC. QA is 5 into 10 power minus 9 plus QB means 10 into 10 power minus 9 plus QC means minus 5. So plus into minus is minus 5 into 10 to the power of minus 9. Okay, here minus 5 plus 5 gets cancelled and 10 power minus 9, 10 power plus 9 gets cancelled. Therefore, we get V naught is equal to 9 into 10. 9 into 10 means 90. 90 divided by root 2 meter. That is 90 divided by root 2 means 63.64 volt. Okay, so we know V naught value and Vd value. Now we need to calculate the work done to move the charge 5 microcoulomb from D to O, right? So for that we have the formula. So now calculate the potential difference dV. In order to calculate potential difference dV, so here dV is equal to V naught minus Vd. Okay. So V naught minus Vd means that is 63.64 minus 31.82. That will gives you 31 means 63.64 minus 31.82 gives you 31.82 volt. Now substitute this in this equation. Therefore, work done is equal to 31.82 into Q naught is 5 microcoulomb, that is 5 into 10 to the power of minus 6. So, if you multiply this 31.82 into 5, you will get 159.1. So, we write 159.1 into 10 to the power of minus 6 joule. So, this is the amount of work done. So, in bringing 5 microcoulomb charges from D to O. The next problem is, in a parallel plate capacitor with air between the plates, each plate has an area of 6 into 10 power minus 3 meter square and distance between the plates is 3 millimeter. Calculate the capacitance of the capacitor. See, they have given area as 6 into 10 to the power of minus 3 meter square. Okay. And the distance between the plates, that is D, as 3 milli means 10 power minus 3 meter. Calculate the capacitance of the capacitor. So here they have not given, so is there any medium between two plates of the capacitor? So if they have not given, that means it is a air capacitor, so parallel plate air capacitor. So if the medium is air in between the two plates of the capacitor, then capacitance is given by an expression A into epsilon naught by D. Therefore, C can be written as A means 6 into 10 power minus 3 into epsilon naught means the value of epsilon naught, that is absolute permittivity of free space, is known to us, that is 8.85 into 10 to the power of minus 12 farad per meter, divided by D, the distance between each plate is 3 into 10 to the power of minus 3. Okay, this 10 power minus 3, 10 power minus 3 gets cancelled, 3 ones are 3 twos are. 2 into 8.85 will gives you 17.7 into 10 power minus 12, so farad. Okay, and this is the capacitance of the capacitor. They have asked to calculate, so if this capacitor is connected to a 100 volt supply, means they have given the potential applied to the capacitor. What is the charge on each plate? See, in a parallel plate capacitor, the two plates of the capacitor have to be identically charged. That is the condition. Okay, so the two plates have the same charge. That means the charge on the first plate is equal to charge on the second plate. Let it be Q. Okay, so then the relation between the charge on each plate and the capacitance and the potential is nothing but Q is equal to CV. We know already the value of C and V is given. Therefore, Q is equal to C means 17.7 into 10 to the power of minus 12 into V means 100 volt. Okay, V means 100 volt. So, Q is equal to 100 means 10 power plus 2, 10 power plus 2, 10 power minus 2 gets cancelled. This is 10 power minus 10. Now shift 1 point. So we will get 1.77. So remaining is, if you shift 1 point, remaining is 10 power minus 9. 10 power minus 9 means nanocoulomb. Here we get Q is 1.77 nanocoulomb. This is the magnitude of the charge on each plate. Okay, so if the first plate is charged positively, then Q1 is equal to 1.77 nanocoulomb. The second plate should be charged negatively, therefore Q2 is equal to minus 1.77 nanocoulomb. This is the charge on each plate of the capacitor. The next problem is, when two capacitors are connected in series across 4 kilovolt line, the energy stored in the system is 8 joule. And the same capacitors are connected in parallel across the same line. The energy stored is 36 joule. Find the individual capacitance. See, here they have given two capacitors are connected in series across a 4 kilovolt joule. The energy stored is, the energy stored when they are connected in series is 8 joule. And energy stored when they are connected in parallel is 36 joule. Okay. So then they have connected across the 4 kilovolt line, that is 4 into 10 to the power of 3 volt. Okay. We know the expression for energy stored, that is U is equal to half CV square in terms of capacitance and so the potential. Therefore, energy stored when they are connected in series is given by US is equal to half into CS into V square. Okay. So now US is given, that is 8 divided by that is equal to 1 by 2 CS into, here CS means the capacitors connected in series combination. So in series combination, the capacitance can be written as C1 C2 divided by C1 plus C2. So we can write C1 C2 divided by C1 plus C2 into V. V means it is nothing but 4 into 10 power 3. So 4 into 10 to the power of 3 whole square. Okay. Therefore, so now take this 2 to this side, we get 8 2s are 16. Okay. That is equal to C1 C2 divided by C1 plus C2 into, so 4 square means 4 4s are 16 into 10 to the power of 3 whole square means, so 10 power 6. This 16 and 16 gets cancelled. Therefore, we can write. So, here, now take this 10 power 6 to that side. So, we write C1 C2 divided by C1 plus C2 will be equal to, when 10 power 6 goes to the left side, it becomes 10 power minus 6. Okay. So, now let us take this as equation 1. In a similar way, the energy stored across the parallel combination is nothing but UP is equal to half CP V square. CP means C1 plus C2. Okay. So, CP means C1 plus C2. Therefore, we write C1 plus C2 into V square means, so it is nothing but 4 into 10 power 3 whole square. So 4 into 10 power 3 whole square means it is nothing but 16 into 10 to the power of 6. Okay. So here UP so is nothing but 36 joule. So 36 is equal to half into C1 plus C2. See, here we can write this 2 1s are 2 8s are. Therefore we can write, so C1 plus C2 into 8 into 10 to the power of 6. Okay. So now take this to this side. Therefore, we can write C1 plus C2 is equal to 36 by 8. 36 by 8 into, so this 8 into 10 power 6 goes here. So 36 divided by 8 into 10 power plus 6. Plus 6 goes numerator and it becomes minus 6. Okay. So here we can write. So here we can write 8 1s are, 8 4s are 32, remaining is 4, then 8 5s are 40, so 4.5. So here C1 plus C2 is equal to 4.5 into 10 to the power of minus 6. Okay. So then let us take this as equation 2. Now substitute this value in this equation. Therefore, we can write C1 C2 divided by C1 plus C2. So, can be written as C1 C2 divided by 4. C1 plus C2 value is 4.5 into 10 power minus 6. That is equal to 10 power minus 6. Now take this into this side. We get C1 C2 value as 4.5 into 10 to the power of minus 6 into minus 6 is minus 12. Let it be equation 3. Okay. So we know one equation regarding the quadratic equations, that is a minus b whole square can be written as, just remember, a minus b whole square is equal to a plus b whole square minus 4ab, right? So now substitute, apply this to this equation. So we can write c1 minus c2 whole square is equal to c1 plus c2 whole square minus 4 c1 c2. Okay. So c1 minus c2 whole square can be written as, that is equal to C1 plus C2 is nothing but 4.5 into 10 to the power of minus 6 whole square minus 4 into C1 C2 is 4.5 into 10 to the power of minus 12. After simplifying all these things, 4.5 into 10 power minus 6 whole square minus 4 into 4.5 into 10 power minus 12. So after simplifying all these, we get 2.25 into 10 to the power of minus 12. Okay. Now take square to this side. So it becomes square root. Square root of 2.25 will gives you. See, 225 square root means 15. So 2.25 square root is 1.5 into 10 power minus 12. Square root is 10 to the power of minus 6. Okay. So now, we have C1 plus C2 value and C1 minus C2 value. By using that, we can easily calculate the individual capacitance, that is C1 minus C2 is equal to 1.5 into 10 to the power of minus 6. C1 plus C2 is equal to, 4.5 here, 4.5 into 10 to the power of minus 6. Okay. So if we add these two, this plus C2 minus C2 gets cancelled. C1 plus C2 is 2C1. 1.5 plus 4.5 is 6 into 10 power minus 6. 2 ones are 2 3s are. So we get C1 is equal to 3 into 10 to the power of minus 6 farad. Okay. In the same way, so in order to find out C2, see, now consider C1 minus C2 equation. Just take C2 to this side. We get C1 minus, now take 1.5 to this side. So 1.5 into 10 to the power of minus 6 is equal to C2. C1 is 3. So 3 into 10 to the power of minus 6 minus 1.5 into 10 power minus 6 is equal to C2. So 3 minus 1.5 is 1.5. So C2 is equal to 1.5 into 10 power minus 6 farad. This is the individual capacitance when two capacitors are connected. So series as well as parallel.